Today we are going to begin a new unit called organic chemistry, and we are going to begin by looking at what organic chemistry is. So, organic chemistry is basically the study of all compounds of carbon except carbonates, carbon dioxide, carbon monoxide, and carbonates as well. So we have said organic chemistry is a study of all compounds of carbon except carbonates, hydrogen carbonates, carbon monoxide, and carbon dioxide. So let's put that down. You're saying this is the study. This is the study of compounds of carbon except carbonates, carbon monoxide, and carbon dioxide. That is organic chemistry. Now, why is the study of organic chemistry important? You realize that carbon has a very, very unique ability. Carbon has the ability to bond with itself unlimitedly, leading to millions and millions of carbon compounds out there, most of which are very useful to us as humans. Talk about the foods we eat. Talk about the medicines we use and many other applications. So the study of organic chemistry is very important because the organic compounds we are talking about are very, very vital to human life. Talk about foods, you talk about medicine, they are all made from compounds of carbon plus other atoms you're going to see. So, carbon has the ability to bond with itself unlimitedly in a process known as catenation. Catenation. So, let's say this, that carbon has the ability to bond with itself, unlimitedly. Unlimitedly means without ends in a process known as catenation. Catenation is the process by which an element bonds with itself unlimitedly. A case in study here, carbon. Now, carbon can bond with itself unlimitedly, leading to millions and millions and millions of carbon compounds. So let's say this, that this ability makes it possible to have a wide variety of organic compounds which are very, very useful, in various fields. Now, we've been talking about carbon bonding with itself unlimitedly. But what is this carbon we are talking about? Carbon is an element in the periodic table with atomic number. So carbon has atomic number 6. Carbon has the atomic number 6. Electronic arrangement, configuration 2, 4. Why is this significant? It means that carbon can bond with other elements, forming 4 bonds because it has 4 valence electrons. So the significance of this is carbon has the ability to form 4 covalent bonds with other elements. Since it has 4 valence electrons. So at any given point, when you're drawing an organic molecule, carbon must be surrounded by 4 covalent bonds. No more, no less. Why? Because carbon has got 4 valence electrons. So it cannot form more than 4 bonds. Neither can it form less bonds in this case, except in graphite, of course. Now, to this end, in this particular unit, we are going to look at various groups of organic compounds. And those groups of organic compounds, we call them homologous series. So we will look at various classes of organic compounds in this unit. These classes of organic compounds are referred to as homologous series. The classes of organic compounds are referred to as homologous series. So, what is a homologous series? A homologous series is a group of organic compounds Number one, with same general molecular formula. So members of the same homologous series, we are going to delve further into this, but here we are saying that members of the same homologous series have same general molecular formula. We're going to look into this. Number two, the compounds have, so you can say have same functional group. We are going to look at what a functional group is. Functional group. Three, they have similar chemical, properties. They have similar chemical properties. Four, they show a gradual. So we can say show a gradual change in their physical properties. And you can say that they are generally prepared or produced, if you may, produced in a similar manner. So these are some of the characteristics of homologous series. Number one, they have same general molecular formula. Two, have same functional group. Three, they have similar chemical properties. Four, they show a gradual change in their physical properties. Five, they are generally prepared or produced in a similar manner. The sixth one, number 6, is that members of the same homologous series members of the same homologous series differ from each other by a methylene or methylene group. Methylene group, as you're going to see, is basically CH2. We are going to see these characteristics as we move deeper into the unit. All right. What are some of the examples? What are some of the examples of homologous series we are going to look at? So, the homologous series we are going to look at are 1. So, homologous series. Okay, number 1, we are going to look at alkanes. These are some of the compounds we are going to look at, organic compounds we're going to look at in this chapter, in this unit. Alkanes. 2, alkenes. 3, We're going to look at alcohols. Alcohols. 4. We are going to look at carboxylic acids. Carboxylic acids. These are the major homologous series we are going to look at. And then on top of that, we are going to look at another class of organic compounds we call esters. And then we talk about polymers. From there, we'll see where to move to next. So alkanes, alkenes, alcohols, carboxylic acids, esters, and polymers. Let's begin by looking at the first. Number 1, alkanes. Alkanes. Now, alkanes are a class of organic compounds which are saturated. So we can begin by saying this, that this is a group of organic compounds. Group of organic compounds with, let's go this way, with only single carbon to carbon bonds. It means these compounds are of this form. They only have single carbon to carbon bonds. We don't have double, we don't have triple, we only have single carbon to carbon bonds. They are referred to as saturated organic compounds. Now, in this case, what does the word saturated mean? Saturated. Let's look at this. A saturated organic compound is one with single carbon to carbon bonds. Only, the word only must be there, that we only have single carbon to carbon bonds. If you encounter an organic compound with single carbon to carbon bonds, then we say that that particular organic compound is saturated. That particular organic compound is saturated. And we can also say that these compounds have a maximum number of hydrogen atoms. Very, very important that they have single carbon to carbon bonds. That's how you define saturation or saturated organic compounds. Then here you talk about the compounds having a maximum number of hydrogen atoms. You're also going to look at this. Now, this brings me to These are the concepts. They are also said to be hydrocarbons. They're also said to be hydrocarbons. Now, what is a hydrocarbon? What is a hydrocarbon? So, by definition, a hydrocarbon is an organic compound which consists of carbon and hydrogen as the only elements. Let's define it this way. A hydrocarbon, this definition is extremely important. In an examination, this definition carries 2 marks. And this is how it will be marked. Let's define it this way. A hydrocarbon is an organic compound. The word organic must be there. Is an organic compound. Is an organic compound with carbon and hydrogen atoms only. Now, this is how the 2 marks will be awarded. Mentioning that it's an organic compound with carbon and hydrogen. 1 mark. Mentioning the word only, another mark. So if an organic compound has got carbon, hydrogen, and then other atoms in it, then that is not a hydrocarbon. The hydrocarbon must strictly have carbon and hydrogen atoms only. Very, very important definition, this one. Together with saturated compounds. These definitions are extremely important. All right, back to alkanes. At this level, we are going to look at the first 10 alkanes. So, we are going to focus on the first 10 alkanes. Not alkanes, rather, sorry. Alkanes. Number 1, the first alkane has the name. Before I give you the name of the first alkane, we have prefixes which we use in organic chemistry. The prefixes are meth. Meth stands for 1 carbon atom. The other prefix, I've not yet given you the alkanes yet. I'm just giving you the prefixes you're going to use in order to be able to name the alkanes. We have eth. Eth stands for 2 carbon atoms. Prop. Prop stands for 3 carbon atoms. But. When I talk about but, but stands for 4 carbon atoms. We go to pent. Pent, even from your mathematics point of view, pentagon, pent, stands for 5 carbon atoms. Hex. Hex stands for 6 carbon atoms. We go to hept. Hept. Hept stands for 7 carbon atoms. We go to oct. Oct stands for 8 carbon atoms. From octagon, from octopus. Oct stands for 8. Non. Non stands for 9 carbon atoms. Dec stands for 10 carbon atoms. If they stretch it a bit and talk about 11, though we are majorly going to talk about the first 10, but you may find mentions of 11 and 12 carbon atoms in your textbook, and as you interact with the questions, we call that one on deck. On deck stands for 11 carbon atoms. You may also find a mention of duodec. Duodec. This one stands for 12 carbon atoms. But we are majorly going to focus on the first 10. So let's begin by looking at the first 10 members. Let's start by looking at the first 10 members. Number 1. There's something else you need to know. That alkanes, we have said these are the prefixes we are going to have. Eth for 1, meth for 1, eth for 2, prop 3, but 4, pent 5, hex 6, hept 7. We have hex 6, hept 7, oct 8, non 9, and dec 10. You need to know something else. That the names of the alkanes ends with the suffix. Ends with the suffix A-N-E. So we are going to have our prefix plus suffix. We are going to have our name from prefix plus suffix. For example, meth plus ane. We have methane. Number 2, eth plus ane. We are going to have ethane. We form propane. For but plus ane, we have butane. 5, we have pent plus ane, we have pentane. 6, hex plus ane, we have hexane. 7, we have hept plus ane. We are going to have heptane. 8, Oct plus ane, we form octane. 9, non plus ane, we have nonane. Finally, 10, dec plus ane, we form decane. Those are the names of the first 10 members of the homologous series alkanes. We have methane, ethane, propane, butane, pentane, hexane, heptane, octane, and nonane and octane. Right. There's something very, very, very important we need to look at when it comes to alkanes. Very important. Let's look at the alkanes have remember, we began by saying that the alkanes or the homologous series generally have the same general molecular formula. So here we are saying that alkanes, this is now very, very important. Alkanes have the same general molecular formula of CnH2n plus 2. CnH2n plus 2. When you hear alkanes, that is the general molecular formula we need to have. CnH2n plus 2. Where n is a whole number, starting with n equals to 1, 2, 3, 4, 5, etc. Now, we have the names of the first 10 alkanes. We need to know how to come up with their molecular formula. Here is how. Let's look at the first member, methane. Meth stands for 1 carbon atom. Okay, let me do it here. Meth stands for 1 carbon atom. All right. 1 times 2. Remember the formula is CnH2n plus 2. So, n, 1. 2 times 1, 2 plus 2, 4. There's no need of writing 1 there. By writing C, we know we have 1 carbon atom. So methane has a formula CH4. We go to ethane. F stands for 2. 2 times 2, because this is 2n. 4 plus 2, 6. So C2H6. That is ethane. Number 3, we talk about propane. Propane has the general molecular formula C3, 3 times 2, 6 plus 2, H8. Butane, C4H, let's see, 2 times 4, 8 plus 2, 10. 5. Pentane. Pentane has the formula C, 5 carbon atoms, H, 5 times 2, 10. 10 plus 2, 12. 6. Hexane. C6H. 6 times 2, 12 plus 2, 14. 7. 7. Heptane. Heptane. C7. 7 times 2, 14 plus 2, 16. Number 8. Octane. C8. H. 8 times 2, 16 plus 2, 18. Number 9. Nonane. Nonane. C9H. 9 times 2, 18 plus 2, 20. Number 10. Decane. C10H. 10 times 2, 20. 20 plus 2, 22. And that is how we come up with the molecular formulas of the alkanes given the number of carbon atoms we have. So I wish to stop there. We will continue from here in our next lesson.